Good morning to one and all present over here. Um, Today's class we are going to see about optical communication. Myself, V. Tamilarasan, assistant professor, working as a working in a ECE department. Today's class we are going to see about introduction to optical communication. Before that, we are going to see about what is communication and why we are going for communication and those things. First, what is communication? So, all of you know that communication is the process of exchanging information. That is, sending out one information from one place to another place. It is called as a communication. Next, and there's another way is defining sending and receiving a message from one place to another place is called as a communication. So, the communications involved basic four process. First one, information source. Second one, transmitter. Third one, communication channel. Fourth one is a receiver operation. There are three types of communications are available. First one is simplex. Second one is half duplex. Third one is full duplex. Simplex communication is a one-way communication. Example, radio systems, TV broadcasting systems. Second one is a half duplex communication. It is a two-way communication. Either one side will be transmit the signal and either one side will receive the signal. It is called as a half duplex system. Example, mm, police, that is walkie-talkie communication, and then family radio. So these things are the example of half duplex communication. Third one is a full duplex communication. It is a two-way communication. That is sending information from uh, one place, the same way receive the signal from a other side. So both the communication will happen in a at same time. So example, normal telephone communication is called as a full duplex communication. Repeat once again. First one is a simplex operation. It is a one-way communication, exchanging the information either only one side, not other side. It is called as a simplex communication. Example, uh, TV broadcasting. Okay, TV broadcasting. Second one is a half duplex communication. It is two-way communication. So sending or receiving information either one side, not for both the side. Example, walkie-talkie communication. Third one is a full duplex communication. It is a two-way communication, sending and receiving the information simultaneously in both sides. So types of communication. There are four types of communication available. First one, analog communication. So in that there are several types. First one is analog amplitude modulation. Second one is a frequency modulation is available. Third one is a phase modulation. So does all of you know very well? Second, digital communication. So ASK, it is a amplitude shift keying. FSK, frequency shift keying. PSK, free phase shift keying. QPSK, quadrature phase shift keying. It is also all of you know that very well. Third one is a microwave communication. It is a high frequency communication. It is communication through radio, microwave frequencies. So it is microwave communication. It is using high frequency band. Last one is a optical communication, exchanging the information from one place to another place through the light signal. It is called as an optical communication. Basic block diagram of a communication system. So there are three blocks are available. First one is transmitter block, second one is a channel, third one is a receiver. The information source, the transmitter, the input of transmitter is the information source, that is which signal we are going to transmit, that is the information, that is the information signal. So example, our voice signal, audio signal, video signal, computer data, traffic signal, like those signals. This signal is sent to transmitter through drive circuit. The transmitter is transmit the information to a channel, that is a transmit to free space. It is called as a channel. The channel will be a wired system or wireless system or a fiber optical cable system or etc. It is called as a channel. And then final box, the receiver block. The receiver is used to receive the signal from channel. The receiver signal should be a information source. This is the basic block diagram of a communication system and then communication process. Normally, transmitter is a transmit the signal. The uh, channel is a medium for communicating the signals from transmitter to receiver. So in the channel, additionally add the noise signal also. So in this noise signal, either noise signal will be added through atmosphere or electronic device or any other parameter. This noise signal will be added to the channel, and through on the signal. So after that, these noise also uh, send to receiver. The receiver will receive both original signal and noise signal in combined manner. So the main task of receiver is receive the signal from channel and also remove the noise signal. So the major task or major design difficulty of receiver is these two process: receive the signal and remove the noise signal also. So basic signals, analog signal. So it is a continuously varying signal. It is also, all of you know that very well. Example, sine wave, voice signal, video signal. These are the analog signal. It is continuously varying with respect to time. It is called as analog signal. Digital signal, it is a change steps or discrete increments. That is logic 1 or logic 0. So if it is high means logic 1, if it is low means logic 0. These are digital signal. So it is also, all of you know that very well. Next is the main module of the communication system is channel multiplexing and modulation. So multiplexing, it is also, all of you know that very well. It is multiplexing is the process of combining more than one signal in a one line. It is called as a multiplexing. Modulation is the simply boost upping the lower signal using carrier signal. It is called as a modulation. So modulation makes the information signal more compatible with the medium. Multiplexing also are the more than one signal to be transmitted concurrently over a single medium. That is, more than one signal is sent to a single output line. It is called as a multiplexing. So this is the basic block diagram of channel multiplexing and modulation system. So multiplexing is a combined many signals into a single line. So based on the timing, it will select the particular input line. So and then pass through the modulator. So the modulator is used to boost up the weak signal using carrier signal. So the carrier signal will be generated from the carrier oscillator, and then power amplifier is the amplify the uh, amplify the signal and then pass through the antenna. This is the basic process of channel multiplexing and modulation. So this is the frequency division multiplexing. Based on the frequency, the signal will be multiplexing. It is called as an frequency division multiplexing. Time division multiplexing is based on the time the signal will be detected. Many multi-modulation formats are also available. Non-return to zero, return to zero. These are the basic communication process and communication parameter and like those. So next is why we are going for optical communication. What is the use we are going to see now? So need of fiber optic communication. So the fiber optic communication is the high data rates, that is high speed of operation, which allow high capacity transmission quickly. That is transmitting the signal long distance, transmitting the signals to long distance with high data rate, that is high speed. It is the major advantage of optical communication system. This also had the potential for a transmission over a long distance without need of amplify and retransmit along the way. So transmitting the signal with long distance without amplify and retransmit and in between the process. It is also one of the benefit of optical communication system. Speed limit of electronic processing, limited bandwidth uh, of copper and coaxial cable. So very high bandwidth up to 30 terahertz, low loss 0.25 dB per kilometer at 1550 nanometer fiber optic window. These are the need. So major needs for three things. One is high data rates, high distance communication. This is 2 points, and then without amplification and retransmitter in between. Their speed bandwidth is up to terahertz. These are all the main advantage of optical communication system. This is the evaluation of light wave communication system, that is optical communication developed from the year. It is evaluation. So starting in 1850, telegraph invented, and then around 1900, telephone were invented. After the year 19,000, uh, so after 1900, the coaxial cable is came out. After 1950, the microwave communication will be developed, and also light wave communications are developed in the around after 1950, the optical communications are developed. This is the chart for frequency and wavelength graph. So in the upper line, frequency values are noted. The lower line, wavelength are noted. We are noted. Um, Twisted pair cable and coaxial cable are the optical fiber cable. The range, frequency range is 10 to the power 10 to 10 to the power of 8 is twisted cable pair. And the same way coaxial cable are used 10 to the power of 3 to 10 to the power of 9. AM radio will be used 10 to the power of 5 to 7. FM radio is used to 10 to the power of 6 to 10 to the power of 9. These are the optical communication. This is infrared communication will be used 10 to the power of 12 to 10 to the power of 14. Visible light communication of 10 to the power of 14 to 15. Optical fiber are used 10 to the power of 14 to 10 to the power of 15 in the range of frequency. It is the major advantage. It is the high speed for while using optical communication. So the basic optical communication. This is the signal. So this is the optical signal in terms of sine wave format. This is the amplitude. This is the wavelength. This is the position slash distance. This electromagnetic wave carry energy from one point to another, travel in a straight line, described in a wavelength. Speed of light in vacuum is 3 into 10 to the power of 8. This is the basic things for light signal. This is the basic block diagram of a optical fiber optic communication system. This is the overall block diagram of the optical fiber communication system. Major elements: source of information, transmitter, optical source, optical fiber cable as a transmission medium, photo detector, electrical stage, designation. This is the transmitter section. Up to these two blocks are transmitter section. This is the channel up to optical source to this block, and then this is the last three modules are the receiver section. This is the basic block diagram of optical communication. This is the overall block diagram of a fiber optic transmission link. The first, so the transmitter section consists of two modules: drive circuit, next one is a light, that is a light source. So drives module, drive block is, so drive the electrical signal to source, that is light source. This is the major process of the drive circuit. Drive circuit is used to drive the electrical signal to source block, that is light source block. Light source may be used as either used as a LED or laser. These two sources will be used depending upon the application, depending upon the design, depending upon your requirements. LED is a light emitting diode. uh, Laser is a light amplification stimulated emission system. Simulated emission radiation. This is the expansion for LED and laser. So these two devices will be used for the generating light signal. And this block will generate the light signal and pass through the fiber optic cable through fiber connector. This is the major operation of the transmitter section. In the electrical signal, normally we are transmitting our voice signal, that is a non-electrical quantity signal. This non-electrical quantity signal is converted into electrical quantity. First point, using transducer. The transducer is used to convert the non-electrical quantity to electrical quantity, and then this electrical signal is uh, sent to drive circuit. The drive circuit will drive the electrical signal to light source section. The light source section will be a LED or a laser be used. The LED or laser is a generate the light signal based on the electrical signal and then pass through the fiber optic cable using fiber optic connector. This is the optical fiber cable. So this is the channel, and also this is the optical coupler. So sometimes we need splitting the signal from 2 points, from 1 point to 2 points. So we are using optical coupler. Then this is the regenerator block. This is the main block of optical communication system. uh, if the signal will transmit a long distance, the energy will be losing, so that again boosting the signal, we need to boost the signal, so that we are using regenerator in the in between the channel. So uh, regenerator consists of a optical module, electronics module, and then optical module. This optical module will be receive the optical signal and then pass through the electronic circuit. In this electronic circuit, just boost upping the signal, that is increasing the amplitude of the signal and pass through the optical block. This optical block is, that is simply we are used as a light source signal, that is the light source device, LED or laser. It is used to generate the light signal and pass through the again channel. So this regenerator will be receiving the optical signal and converted to electrical and boosting the electrical signal and then again converted to light signal. This is the process of regenerator. Then pass through the optical cable. Finally, optical uh, finally receiver section receive the optical signal from the cable. So from the cable, wait, from the cable having a light signal, and also the light signal is mixed with the channel noise. Okay, in in that place, the in that place, light signal, that is original our data plus original our data in the form of light plus channel noise. The this block, photo detector block, this photo detector maybe will be used as a pin for either pin photodiode or avalanche photodiode may be used depending upon the cost constraint, depending upon the application, and also your design, your requirement. Based on the choice, we are choosing either pin photodiode or avalanche photodiode. This diode will convert light signal to electrical signal. In that electrical signal, send to amplifier block. In that amplifier block, having a amplifier and a low pass filter signal. So the low pass filter is used to remove the noise signal, and then amplifier is a so increase the strength of the signal. Last is the signal block, signal restorer. This in the circuit having a decision circuit. So decision circuit, it is a decide the whether the decision circuit will be either, that is decision circuit will be design the level of the output. If it has reached the above level, so send this signal. If it below means send this like a signal. So this is the decision circuit. This is the and then pass through the required designation of the receiver. Mm. This is the overall communication of the optical fiber optic communication system. There are three blocks: transmitter, regenerator, receiver. Transmitter transmit transmit the light signal from the electrical signal using LED or laser. The regenerator signal block is used to regenerate, that is receive the optical signal and then convert it to electrical. So the electrical signal is increasing the strength and then again converted to optical signal. This is the process of regenerator. Receiver section receive the light signal from the channel and detect electrical signal using pin or Avalanche photodiode, and then amplify, filter the channel noise, and then send it to decision circuit. So finally it will reach the user designation, receiver designation. This is the overall block diagram of the optical communication system. So this is the overall block diagram of optical transmitter. Consists of light source, external modulator, attenuation. This is the overall circuit diagram of the optical transmitter. This is the receiver section block diagram. It is already explained. The advantage of optical fiber communication system is a increased bandwidth, increased bandwidth and channel capacity. So low signal attenuation, immune to noise, no crosstalk. That is crosstalk means so we are using different wavelength range, so that not possible to interfere with the adjacent channel, so that the no crosstalk will be occur. Lower bit error rates, and then signal security, because using wavelength, so that signal will not be hacked any other person, so the signal security will be high. Electrical isolation is there, reduced size and reduce weight of cables, radiation and resistance, and the environment friendly, resistant to temperature variation. These are all the advantages of the optical communication system. Major advantages are high speed, high bandwidth, and then low signal attenuation, no crosstalk, signal security. These are the main five advantages of the optical communication system. And also use long distance communication, the speed up to terabytes. Disadvantage of optical fiber communication system. Uh, skills needed, specialized skills needed. Cost of installation, one time cost installation is high. Cost of retransmission equipment from electrical to optical signal is high. Optical fiber cannot carry electrical power. These are all the four disadvantages of the optical communication system. Next, the applications of the optical carrier communication system. Some optical fiber very flexible. They are used in the flexible digital cameras. Fibers used in a mechanical imaging. That is inspection of mechanical wells in pipes, engines, rockets, space shuttles, and aeroplanes. Fibers used in the medical imaging, that is medical equipment, such as endoscope, laparoscopic systems. Cable used in the sea communication, that is underground communication in river. Uh, Fibers are used in a military applications such as aircraft, ships, tanks, and etc. Nuclear testing applications, optical fiber phase sensor and transducers. Optical fibers used in a public utility organization like railways, TV transmission, and etc. Fibers are used in a LAN system of office, industrial plants, and colleges, etc. The fiber optic is used in telecommunication such as voice, telephone, video phones, telegraph service, messaging service, and data networks. These are all the applications of the optical communication system. So, any queries regarding introduction to optical fiber communication system? This is the main. This is the main advantage of our fiber optic communication system. So mainly high speed with long distance communication, increased bandwidth, and then no crosstalk, signal security. These are all the main advantage, and also reduced size, reduced weight of the cables. These are all the main advantage. Thank you for today's class. So next class we will see about introduction to optical fiber modes and configuration, fiber types, and fiber cables. Thank you. Thank you for listening the class. Thank you to all.